So, hello everyone and welcome to another Würth Elektronik ISOS webinar. My name is Markus Eberle and I will moderate this webinar today. We are very pleased that you took the time to participate in our webinar today. Yeah, and the topic of today's webinar is retrofitting for industrial IoT using Wi-Fi. Our speakers today are Aditya Madanahalli, who is working as an IoT engineer at Würth Elektronik ISOS, and also Manfred Schommerz, who is working as technical support engineer at Würth Elektronik ISOS for the section wireless connectivity and sensors. So they will hold today's webinar and also answer your questions. So before we start the webinar, I would like to point out one thing. You will be muted during this webinar today. That means that you cannot ask us questions via the microphone. Nevertheless, you have the opportunity to ask us questions with the chat function, and you will find that in the webinar control panel. The webinar will be about 30 minutes long, and the chat questions will then be answered after the session, after the presentation, and we have scheduled for this also 10 to 15 minutes. And if we are unable to answer all your questions within this time, we will answer them later on. And you also have always the chance to send us an email at webinarteam@we-online.com. We will also send you the link to the presentation as well as to the recording of this webinar only in the next few days. And now I'm happy to introduce or to give over to Manfred and Aditya, and I wish you an exciting webinar.
Yes, well, okay. Good afternoon, ladies and gentlemen. Thank you for joining us this afternoon here. Adi and myself will be representing this interesting topic of retrofitting and IoT using Wi-Fi for old machines which might run out of practical use. And let's kick off with the next slide.
Warm welcome to you all from my side. Glad that we have you all online here today. So let's proceed without further ado.
Yeah, the agenda, we have a few points that we'd like to go through. We'll start off, the first topic, point one, is retrofit, make new from old. In other words, an old machine which we'd like to retrofit in order to make it usable and new again. We've discussed a little bit the points of retrofitting, the benefits, and we'll go through an example use case. We would like to then actually retrofit using our Calypso Wi-Fi module. And most important, that's why we highlighted it, a live demo. Now that's a real challenge for this afternoon, and we'll swap our cameras and hopefully show you via one or two cameras the equipment we're using here, our Calypso Wi-Fi module and a computer, laptop, and a machine that we would symbolically try to retrofit in order to communicate with it. But without further ado, right at the end, some questions and answers, but let's carry on with the first slide here. The question that is posted here, how do we make an old machine IoT capable? Because all modern machines nowadays are very much IoT capable, which sensibly makes them much more useful and valuable in order to be more productive. In essence, we want to convert an old machine into a smart machine. Adi, what have you got to say?
Yes, as you see here, we have, that's for example, a machine which is old, but it's still working. What the engineer says, do not disturb a working system. But we can supplement it with additional sensors, a state-of-the-art wireless connectivity solution, so that you can bring the data of the machine onto the cloud platform, onto an IoT platform. What are the benefits of this? So when you have data on the IoT platform, the first thing is you can visualize it. So like we say, a picture tells 1,000 words. So the data just visualized gives you a lot of insights into the processes, the status of the machine, and so on. With this, you have opportunities to run additional algorithms, process your data to achieve a lot of additional benefits. For example, quality control, process optimization, process automation, predictive maintenance, and so on. So as you see, there are a lot of benefits of making any old machine IoT capable. So that's more or less what we call, retrofitting.
Yeah, I see here remote monitoring and control is one of the benefits. In other words, we get a whole lot of new business models, and we make the machine smart. Now, what are the actual benefits? Yeah, the question I see very often is a financial question. And obviously, if you want to retrofit something, there must be a financial benefit. The potential of retrofitting is interesting. Most large CNC machines are 20 years and older, but still very much useful. And this is a source by the VDMA, the Verband Deutscher Maschinen- und Anlagenbau. And 85% of all industrial plants in Germany are not digitally connected. Also the source by Accenture. Now this shows me that many machines could actually be retrofitted, and that's why you see this red arrow pointing upwards. The benefits are enormous. Maybe the benefits of retrofitting, Adi?
Yes, as you see, I mean, the really visible benefit is that you can extend the useful lifetime of the machine by 5 to 10 years, which is really, as you can see, 50 to 100% or percent of the lifetime of the machine without using retrofitting. So that's a really significant benefit of using retrofitting. Additionally, you also have reduced training efforts. So the users are already accustomed to the old machine. They don't have to be trained again and again, which reduces the fear of digitalization, which is kind of already the ongoing trend in the industry now. Not to forget, it is good to the environment. So we are reusing the machine, not sending it to the recycling bin, so to say.
Yes.
When we look at a typical example, this is from a study from Bosch Rexroth, that by investing as less as 25,000 euros on, this is not just one machine, on several machines here, of course, they could achieve an annual savings of up to 200,000 euros. That is really significant.
Excellent, yes. And I see here the last point, investment actually pays off within 2 years. So a little bit or a small investment pays off within 2 years, and you extend the lifespan of the machine by a considerable amount.
Okay, I mean, let's consider a concrete example for our use case, today. As you can see, we have taken the example of a CNC machine. Manfred, can you elaborate a little more?
Yeah, in fact, most of the machines, 15 years old CNC machines from hardware, which are available in industry, very often still have a proprietary control software, a software not linked to the outside world. They have an IoT, hopefully compatible interface, but at this stage, very often only via RS-232 or RS-485 or some other wired system, and with a proprietary software control. Now, the issues here are actually manifold. Very often you have unplanned downtimes because you can't control the machine in the way we can do it nowadays with IoT. Stagnant material supply, increasing rejects, and also expensive service and maintenance contracts.
So we're talking about quality issues, and for example, in charge of a factory floor what he would do is use manual records to record all the faults and try to see a pattern, but it is too much when the scale and number of machines are really huge. Another really important factor that we can consider is that when we try to tamper with the internals of such a machine in order to repair it, make it better, optimize it, we have the service contract which goes void, which means it can be really expensive. In summary, what we need is a non-invasive method to monitor and control the machine, to preempt and plan the downtimes. So that is what is the need of the hour, let's say.
Yeah, okay, here we have a real world example, retrofitting as the rescue to our problem. And Adi, maybe you can explain.
So this as we were speaking about the non-invasive method, so this is exactly what we want. So we have a machine which has an let's say an RS-232 or a serial interface, which is typically wired. So the first step in providing a non-invasive solution to monitor and control the device would be to provide a wireless connectivity, which can connect the machine directly to the cloud. So this brings the data from the machine to the cloud. Step 2 would be then augment this machine data with additional data from sensors. So you can mount vibration sensors, acoustic sensors, optical sensors, current sensors, and so on, which will give you additional information about the status of the machine. And the step further would be to easily visualize the data that comes through from the connectivity as well as the additional sensors. Just looking at the data will give a lot of insights for improvement, process optimization, and so on. But we can go ahead with step 4, where we say we use machine learning algorithms, to perform predictive maintenance, so that we can order parts already well in advance before the machine already has a anomaly or a flaw, and thereby we have optimize the process, zero standstill times, and so on. Which means retrofit is the non-invasive method which reaps complete benefits of the IoT. In today's webinar, we are going to focus on the first point here about wireless connectivity or adding wireless connectivity to old machines. How do we do this? And which brings us to the next slide.
Yeah, I see the next slide here. Wi-Fi fit for retrofitting. Why Wi-Fi? Oh, well, quite simple. Just about every home and house and building has some other access point or Wi-Fi already connected to the big wide world and internet. So we can use the existing infrastructure to actually start off with. And then we just need to connect our machine. And this is where Adi comes in with his IP connectivity.
Because, yeah, I mean, Wi-Fi also provides IP connectivity, which is the basic requirement to connect to the cloud. So that is already out of the box with Wi-Fi. And when we talk about wireless connectivity, we talk about 3 fundamental pillars of wireless connectivity, which is the range versus energy versus throughput. As you can see in this graph, in comparison to other communication technologies, Wi-Fi is in the sweet spot where you have a range of, let's say, 50 to 100 meters, which is really good for indoor environments inside, let's say, a production hall. With the energy consumption, which we are going to show this to you a little bit later in our slides, that it is also low energy as well as sufficient throughput to send sensor data from machine to the cloud. So Wi-Fi is kind of the best connectivity solution to get started with IoT.
Yeah, okay. Now we would actually like to present a Wi-Fi based retrofitting solution using our Calypso Wi-Fi module. Before we show that, here actually a few statistics on our Calypso. You see the beautiful little picture on the right-hand side. Well, it's a fully featured 2.4 gigahertz Wi-Fi module. Support to IoT connectivity in protocols like MQTT and HTTP. It's a very small and easy fitting size, can be integrated quite easily.
Moving on, we have taken care of security by design, which means it has secure board, secure storage, state-of-the-art WPA3 security TLS, and as promised, low power optimizations of around 1 milliampere of current consumption also when connected, remote GPIO control, and typical AD command interface with UART as the primary interface. And the most important feature for today's application, the UART to Wi-Fi bridge mode, or we call it the transparent mode. This is the feature that we want to present today, and this is also the best or the best fitting feature for retrofit applications.
Okay, yeah, we have 2 components here, our Calypso module plus the UART to Wi-Fi bridge.
So what does this UART to Wi-Fi bridge do? It basically functions like this. So once the module is configured with the help of either web interface or the AT command interface, it can be made to function as a TCP server, client, UDP, or including the security, the TLS version. Once started in the transparent mode, the module automatically connects to a pre-configured Wi-Fi network, creates a socket for communication, connects to the peer, and once the connection has been established, all the data that comes over the UART interface of the module will be forwarded to the Wi-Fi, and all the data that comes over the Wi-Fi will be, on the other hand, forwarded over the UART. Additionally, a cherry on the top, you can use the power save mode with an average current consumption of less than 2 milliamperes again, which adds really benefit of battery power operation, for example.
Yeah, okay, lovely. Let's have a look at the next slide. This is what our setup is going to look like. Some machine, whatever type of machine it is, with an interface. In this case, let's take RS-232. I mentioned it, the RS-232 to UART interface, talking to the Calypso. The Calypso, the Wi-Fi module, would then talk to the internet, to the access point, and we into the cloud. Now, the Calypso takes care of the TCP, MQTT, and the physical and MAC layers.
So all we need is just connect the RS-232 via UART to the Calypso module, and the rest is taken care by the module itself. So this is really easy. All that is left is to come to our demo today. So this is the setup for our demo. Let's see. I mean, of course, we cannot bring a CNC machine into our webinar room today, for which we have to settle down for another device. The device that we'll be retrofitting would be programmable power supply. So that is which has an RS-232 interface. Doesn't matter if it is the same thing, whether it's a machine or a power supply. So we just want to show this that it works. What we also do is additionally use our feather wings. Maybe a little bit about that. These are really small form factor modules that are compatible with the other fruit feather ecosystem. The keyword here is rapid prototyping. So you stack these boards on top of one another, and then you have something that is already running. So no soldering necessary. Use the USB as a power supply, and you can already implement your use case.
Okay, in order to get going, there are two very important steps. So one is actually the provisioning to set up, to configure, and then the second step would be the actual execution, the demo.
So what happens here is in the configuration phase of our demo, we will use the provisioning mode of the Calypso Wi-Fi module on the Calypso featherwing. So this will switch the module into access point mode with an SSID of Calypso _ the MAC address of the module.
Yes.
We can use, for example, our laptop today to connect to this access point and open any browser and type in calypso.net, which will then provide the configuration pages of the Calypso Wi-Fi module. Through these web pages, you can intuitively configure the module to connect to the right peer and connect to the right Wi-Fi network and so on and so forth. Once the configuration is done, we switch to the operation mode.
Yeah, okay, lovely. And I see the operation in essence, we take control of our device, which has been retrofitted, communicating over RS-232, and the UART to Wi-Fi bridge mode connects to our access point, and our TCP server could in fact be anywhere on this wide big world. So we could even from Australia or New Zealand talk to our device machine here in Germany. So this is the actual setup as it would be running. Observe the addresses which we placed underneath the TCP server, the gateway, and our Calypso on the left-hand side. So this is the setup. I think it's time to actually start and get going. Now we're going to do a bit of technical switching here and hopefully display our monitor, our cameras. This is Ari and myself, and let's see the camera of the actual equipment.
All right.
So Marcus, that's okay. You see what we have here is in fact our three boards, the bottom being the power supply, the power for the units, our RS-232 to UART converter, and this side would be the connection RS-232 to our power supply here, which at this stage is off, and right at the top we have our Calypso Wi-Fi module.
The feathering.
The feathering. Let's actually get it going and switch on. I'm going to power it up, and there we are. I need to just get the power running. One second. There we are. That's a demonstration. Now it'll take a few seconds to actually get up and running.
So before we do that, what I do is pick off the jumper here and set it correctly so that we go to the step 1 of the demo, which is
the provisioning
mode.
Okay.
Exactly.
First step, provisioning, and we do that via the top. What we have here is our laptop connected to this monitor, and Ari will hopefully show us.
So the module is already in the provisioning mode, so that you should be able to see. Manfred, if you can show the monitor a little bit.
Yes, we'll zoom in a little bit.
So there is the Calypso_MAC address. So let us connect to this one first. In the meantime, I'll open a browser and type in calypso.net. You can see the configuration pages are being loaded. So this is the home page where you can actually add the Wi-Fi network. You can actually select and add the Wi-Fi network. I have cheated a little bit and pre-configured and added our Wi-Fi network already, just to keep a little bit of time in mind. I click on apply for the device mode because when we use the transparent mode, the module will be in station mode. All right. Okay. Now we go and set up the transparent mode. That is under the tab user settings, into the set function. Let's select the transparent mode with the drop down here and go for the socket type. This will be TCP client and post. Now I have already configured the remote address and port. I can show this to you here. So when we go to the transparent mode, we have the remote address. Just take a note of the remote address here. It was the same which we showed you in the slides before. So yes, this is the correct server address. And the last thing to check would be the server port. As you can see, 1337 is the server port. That's it. The module is now configured. Once the configuration is done, we move to the live mode of operation, for which I take the jumper again. Manfred, if you can show us the hardware.
We'll zoom a little bit out here to capture our hardware. Ari is just jumping the device again.
Now I can switch my laptop in the meantime to connect to the access point and then restart.
Okay, we restart our Calypso
module.
And it should now be in the operational mode.
And stop and start our TCP server here.
There we are.
There we are, as you can see.
Something's happening.
Just to show you the hardware a little bit, all the 3 LEDs are glowing here, red, yellow, and green, showing that the connection is established, which you can see also on our TCP server here. If you can zoom in on the screen a little bit. So there is a connection from the IP address 192.168.178.95, which is basically our Calypso module. Let's see if the connection is working with the help of a ping. So
okay, Ari, theoretically, you could now be sitting in Australia talking to my machine here, our power supply, and let's actually see. Let's switch on the power supply
first and then try to send a few commands.
Okay, the process here is actually Ari giving a command on his server here. The command would go out to our access point standing next door, and then the signal would come back
over the Wi-Fi, exactly,
to our Calypso here. The Calypso, in combination with the UART to RS-232 converter, would actually talk to our power supply. Right.
As you can see, there is, when I send a beep command, I mean, it's really not so audible, so you can't hear the beep, but the module is, the power supply is responding already. Let's see if we can send some command where we ask for the version and identity of the power supply.
Yes, I might just add, actually, we have a whole row of LEDs connected to our power supply here, and we'd actually like to switch them on and off via the internet.
Exactly. So as if you can zoom in here a little bit, I have sent the version skippy command. I've sent this command and have received a response from the device, which shows, which can be seen here a little bit. This is the type of the device. HMP 2020 is the type of the device. The hardware version is something here, and the software version is 5.2.1.
Okay, so that's the information you requested from the power supply we have here.
So
and
the next step, I would say, would be let's configure the power supply itself by sending a few commands.
Yeah, sure. Okay.
I will
eager to see what's happening.
Let me type in a few commands. So let's type in a command to select the channel 1. And the next step would be to set the voltage to 12 volts. So currently it's 12.2 volts. And let's see.
Okay, observe down here, we switch to 12 volt.
Let's set the current limit to 1 ampere, right? And send the command. And
there we are, 1 ampere. All these commands going over the internet
exactly.
via our Calypso module.
Now, what I would do is, without further ado, switch on the LED strip.
The big moment. I wonder what's happening.
Let's see, and
Adi.
here we go.
Wow! Ha. Okay, excellent. We have a row of LEDs being driven by our supply. I could have switched this from Timbuktu, if you wish.
Yes, that's the power of IoT, as you can see.
Okay, in the same way, I could actually request data back.
Yes.
We can maybe switch them off as well.
Yeah, let's do this, and it should be now switched off.
There we are. Okay, switched off.
That's, I think, as you can see, the whole retrofitting solution. In this case, we have used the power supply, but this can be any other machine. So all you need is to understand what commands that the machine speaks and speak the same language. But in general, you have the command and control of the machine wirelessly over the internet from anywhere in the world.
Okay, excellent. Adi, thank you very much. In the meantime, let's switch back to the other camera. And we have some time, I think, for questions and answers. Adi, thank you very much for the demonstration here. I enjoyed it. It was great, cool. Could have happened all over the world. And
I hope you have some questions for us now.
I must just quickly check and see the chat forum here and see what is happening. Anything relevant? One of the questions here was, is the connection between TCP client and server secure? I think you touched on it. Adi, maybe tell us a bit more.
Yes, I mean, currently in this particular demo, we have used standard TCP, but it is, of course, possible to use TLS. So TLS, in this case, would provide authentication and end-to-end encryption, which means it will be a secure link from the machine to the cloud or to the TCP server in this case.
Okay.
Also, maybe it's interesting to note that we have used WPA3, which is state of art for Wi-Fi security. So those are the two security aspects here. I have a question here that says, will this webinar be available for later view? I think yes. I think this webinar is being recorded and will be available later. I think we will email you the links.
Yes, as Marcus mentioned,
exactly.
All the data will be made available. You'll receive an email with a link and an update. Apart from that, you're always most welcome to actually ask us further questions. If you require any help, the technical support link on our homepage, make use of that.
Yes, sure.
It ends up on my table, and myself and Adi will certainly try and help you. Maybe one more question I have, Adi, is can the configuration of the Calypso module be done via cable?
So in this case, what we did was use the web server to perform the whole configuration, but it is also possible to use a standard setup where we have a host microcontroller that talks to the Calypso module over the UART interface with the help of ET commands. And you can do all the configuration, which we did using the web interface also through ET commands. It is possible, yes.
Oh, okay, lovely, thanks. I'm keen, I'm very glad we got this demonstration running. Excellent. It's still running next to us here. I'll play around a little bit more with it afterwards. Maybe just a little interesting question. What sort of range can we talk or expect with the Calypso module?
With the Calypso module, we are dealing with the 2.4 gigahertz frequency band, which is already which acts as the physical limit for extending the range. And the factors we have to consider is that the Calypso module has an onboard antenna, which is the PCB antenna, which will give you a limited range, but it is with our smart antenna technology, so you can switch to use an external antenna, which will definitely extend the range. And when we are talking about 2.4 gigahertz Wi-Fi, we are talking about ranges anywhere between 25 to 50 meters indoors. So, I mean, you can talk about line of sight, which is not practical in industrial environment. So we have to be practical to say it should be anywhere between 25 and 50 meters, depending on that.
Okay, so for most factory floors, this should be more than sufficient.
Exactly, yeah. And just to note that we do not deal with I mean, although we are we talk about Wi-Fi 6, 802.11 AC and so on, these are technologies where you deal with really high throughput applications. And in this case, we are dealing with sensors and few bytes of data. We really don't need that much of throughput, which means we can use the standard 802.11 BGN Wi-Fi and still achieve the same results. So that's
one of the questions I always get at the end of a show like this is, what does it cost? I really couldn't tell you. Get in contact with one of our salespeople and they'll give you any answers you'd like to have. Certainly, I think this is worth a while. It can't be that much. An interesting opportunity to retrofit your machine to make it available into the internet, into the cloud, in order to add a few more years of life and use for your machine.
A question here regarding the feather wings. The question is it the same feather with Adafruit? Yes, it's really true. So we have we are compatible with the feather wings. We are compatible with the Adafruit feather ecosystem. So we have all of our feather wings. We have the sensor feather wing, the wireless connectivity feather wings being Calypso and Thione for the proprietary wireless connectivity, and the Magic Power feather wing to have power supplies from a typical industrial rail, so that you can really get your prototype going in a few hours, let's say. And we have this. These are all open source, available on GitHub, so you can download some source codes compatible with the Adafruit M0 Feather Express and build your own prototype. Maybe the next retrofitting prototype.
Yeah, give us some feedback.
Inspired from a little bit of demo what we have done today.
Yeah, okay, lovely.
It would be great to hear from you with the feedback of what you think about the whole.
Order your evaluation kit.
Sure, why not?
Okay, with that, I think we could possibly hand it back to Marcus. Marcus, would you like to take over again?
Yeah, of course. So thank you very much to both of you for really interesting presentation. I really enjoyed it to listen to both of you, and yeah, really cool live demo. So thank you very much. I also hope you enjoyed it.
Risky.
What do you mean? Sorry, I couldn't understand it.
Well, I say a live demo is always risky, but no risk, no fun, eh?
Yeah, thanks.
Yeah.
Thanks to the colleagues here in the town of Trier, Manfred and Bodo, for the whole webinar setup. It's really cool.
Yeah, really cool to work with the colleagues together there. So I also hope you enjoyed the webinar. As Manfred and Adi also mentioned, if you have any questions left after the webinar, just email us. Always welcome. And now also I hope you enjoyed it. And yeah, that was our webinar to the topic of the retrofitting. I hope you will hear us also at our next webinars. And for now, I wish you a good day. So thank you very much and goodbye. Have a nice day.
Have a nice day. Goodbye.